Hey, so I'm not starting with a shared screen for this video. In this video, we're going to be talking about circles. You know what a circle is. I know what a circle is. Almost everyone, at least in North America, knows what a circle is by the time they're 4 years old. Have you ever stopped to think about how you would define what a circle is? If you truly had to say, put down mathematical language describing what a circle is, or even just English words describing what a circle is, in a way that you could then use equations to describe it. You probably haven't, but before we get started, it'd be great to spend 3 to 5 minutes thinking about how you would define a circle in mathematical terms. So pause the video, think about that. I'll share my screen and we'll get started. All right. So hopefully you thought about how to define a circle, and we're going to give a mathematical definition right now. So if we have a circle in a 2D plane, we let HK be a point in that plane. Then we say the circle of radius R, where R is some positive number, centered at HK, is the collection of points that are a distance R from HK. So if we start with a graph and a point here, we'll call that HK. Then the circle of radius 3 is all of these points that are exactly a distance 3 away from them. And this is probably similar to what you would have done in high school geometry with a ruler and compass, where you take your compass, you measure out the length you want, so in this case 3. You put the sharp end at the point at the center of the circle, and then you spin it around. So that then would have hit all points within a radius of 3. So this is a good geometry definition of a circle. It doesn't let us use equations yet to describe the circle, but it's close. In some of the previous videos, we talked about the distance formula. That's going to come back because we were talking about the points that are a distance R from HK. And so using the distance formula, we can quickly derive what we call the standard form for a circle. So derivation is quick. If xy is on the circle, then we'll have that we have R is the distance from x minus h squared plus y minus k squared. So this is just the distance formula. And now we'll take both sides and square them. So r squared equals x minus h squared plus y minus k squared. So therefore, this equation describes any 2 points that are on the circle. And so as a quick example, if we want to find the equation of a circle centered at 1, 2 with radius 3, we'll get the equation 3 squared, because 3 is our R, equals x minus, in this case, our h is 1 squared, plus y minus 2 squared. And that's the equation of a circle. And often we'll just write out the 3 as it's squared. And we can draw a little graph. We have switch to blue. We have a center at 1, 2. And then we're going to look at the points that are a distance 3 away from it. I like to just find 4 easy points to find, and then just draw the circle that connects those 4 points. So the 4 easiest points are moving 3 units up, 3 units down, 3 units to the right, and 3 units to the left. And then we just draw in a circle that connects. And that's it. All right. And sometimes we want to use the equation of a circle to find x and y intercepts. More generally, we'll use it to try and solve equations with lines and quadratics later on, but we're going to start with just the x and y intercepts because it's easy. At least easier than what else. So if we want to find x-intercepts, so that's where it intercepts the x-axis. That would be this point and this point. Then we already know that for the x-intercepts, that y equals 0. Because clearly we're already on that line where y equals 0. So then we just have to figure out what the value of these x's are. And it's pretty quick. We just go to our circle formula, and so we take 9 equals x minus 1 squared plus y is 0 minus 2 squared. So that's going to give us 13 equals x minus 1 squared, or that the square root of 13 plus or minus equals x minus 1. So that 1 plus or minus the square root of 13 equals x. We don't know how to evaluate that quite yet, but we know it's a little bit less than the square root of 16, which is 4. So maybe we're safe in saying this is about 3.7. And then it also asks us to find the y-intercepts. So that's going to be this point and this point. This is a good place to pause the video and think about what we're going to do next. All right, so hopefully you realize that now we're going to do almost the same thing, except for the y-intercepts. That says we're going to set x equals 0. And then we get 9 equals 0 minus 1 squared plus y minus 2 squared. Or that 10 equals, sorry, not 10, negative 8, or positive 8 equals y minus 2 squared. My work's getting really messy. I apologize. And that will turn into 2 plus or minus the square root of 8 equals y. I skipped some steps in this computation, so please fill in the details. All right, so that's it for circles right now. The important takeaway is what the standard form of the circle is and its connection with the distance formula. Both of those are crucial. All right, I hope you enjoyed this.